friends, today we are going to study about the topic electric current and its effect. Last class we discussed about some portion, right? Today we are going to discuss about the remaining topic. Take page number 163. Take page number 163. What is our topic name? Heating effect of electric current. Okay, heating effect of electric current. Here there is an activity 14.3. Okay, now we are going to make a circuit. Okay, first we want to take what? 10 centimeter long piece of nichrome wire and tie it between the two nails. See the picture, ma? They are tying the wire with the two nails from an electric repair shop, or you can use a piece of discarded coil of an electric heater also. Then touch the wire. Now switch on the current in the circuit by moving the switch to the on position. After a few seconds, touch the wire. What happened? What happened? Then we want to switch off the current. Then touch the wire again after a few minutes. What happened? There is a heat occur, right? The wire gets hot when an electric current passes through it. This is the heating effect of an electric current. If you are, for example, if you are switching on a bulb, after a few seconds you touch the bulb, what happened? Switch off the bulb and touch the switch off the bulb and touch the bulb means what happened? The bulb is very hot. Likewise, the wire also very hot. So it is called what? Heating effect of an electric current. Then you might have seen an electric room heater, right? Or a electric heater used for cooking. All these contain what? Coil of wire. This coil of wire is called what? Element. What we call the coil of wire is element. Okay. Element is situated in what? Electric room heater or electric heater. Okay, for cooking and all we are using electric heater, and also for bathing and all we are using electric heater. Inside the electric heater, what is present? Coil of wire. The coil of wire is called what? Element. Okay, then the amount of heat produced in the wire depends on its material and also length and thickness. Thus, for different requirements, the wire of different materials and different length and thickness are used. Okay, the amount of heat is produced based on what? Material, their length, their thickness. Okay, thus for different requirements, the wire of different materials and different length and thickness are used. The wire used for making electric circuit do not normally become hot. On the other hand, the elements of some electric appliance become so hot. They are easily visible to our eyes. Okay, some wires may not become hot. Some elements of some electric appliance become hot in the other hand. The filament of an electric bulb gets heated to such a high temperature, then it starts glowing. Some elements what? Become heat and then the bulb becomes glowing. Okay, some elements. Then here activity 14.4. Here also we are making what? Circuit. Okay. Replace the cell with a battery of 4 cells. Okay, see the picture, they have used 4 cells. Then also in a place of nichrome wire, tie a thin strand of steel wood. Then if there are any fan in the room or switch, then off. Now place the current through the circuit for what? Then place the current for the circuit for some time. Then observe the strand of steel. Okay. The wire make from some special materials melt quickly and becomes break when large electric current are passed through them. Okay, these wires are used for making electric fuses. Wire made from some special materials melt quickly. Okay, and break when the large electric current passes through it because of heat. Okay, these wires are called what? Electric fuses. See the picture? Fuse used in buildings. Then fuses used in electric appliances. Okay, in building and all, in our house and all, we are using this type of fuse, 14.4 14 fuse. And in electric appliances we are using what? 14.15. This picture is a fuse. Okay, then in all buildings fuses are inserted in all electric circuit. There is a maximum limit on the current which can safely flow through a circuit. They use what? Maximum number of current. If by the accident the current exceed, the safe limit the wires. Okay. If any accident came means the wire safe limit the current. Okay. Then may become overheated and may cause what? Fire also. Okay. If there is any accident, the current exceed safe limit. The wire becomes so heated and overheated and it become what? Fire. It make fire. So if a proper fuse is there in a circuit, it will blow off and break the circuit. Okay. If there is a power fuse means what they do? It break the circuit. Then a fuse is thus a safety device which prevents what? Damage to electric circuit. Okay. Yeah. Fuses help to prevent what? Damages to the electric circuit and possible fire. Okay. It prevent what? Damages to electric circuit and possible fire for that. Okay. A fuse is a safety device which prevents what? Damages to electric circuit and possible fires also. Then fuses of different kinds are used for different purpose. Fuses used in our houses are shown in picture 14.14, and in electrical appliances we are using this type of fuse 14.15. Okay. Then the next topic is magnetic effect of electric current. Here also there is an activity. Okay. First we want to take what? Cardboard tray. From inside a discard matchbox. See the picture ma? They have used a cardboard tray and inside they have used what? A discarded matchbox. Then wrap a electric wire a few times around the cardboard tray. See the picture? They have wrapped the electric wire around the cardboard sheet. Then tray. Okay, cardboard tray. Then place a small compass needle inside it. See the picture? They have inserted compass needle inside the matchbox. Then now connect the free ends of this wire with the electric cell. See the picture? They have connected with the cell. Battery symbol is small line and also big line. It is a battery symbol. Then now connect the Then note the direction in which the compass needle is pointing. Then bring a magnet near the compass. Okay, then observe what happens in the compass. Okay, then move the switch to the on position. Then see what? Observe the compass. What happened? Move the switch back to the off position. What happened? Does the compass needle come back to its initial position? The needle of the compass is a tiny magnet which points to the north-south direction. So, if we bring a magnet close to it, what happens? The needle gets deflected. We have also seen that compass needle gets deflected when the current flows in a nearby wire. We know already, we studied that, right? Okay. If we get a compass needle get deflected when the current flows in a nearby wire, so only there we are switching on the current. When current flows through a wire, does the wire behave like a magnet? Thus we are observing, okay. When electric current passes through a wire, what happens? It behaves like a magnet, okay. When the current flows through a wire, what happened? The wire became like a magnet, behaves like a magnet. So this is a magnetic effect of what? This is a magnetic effect of what, ma? Electric current. Okay, it is a magnetic effect of electric current. A scientist called Hans Christian Ørsted also wondered. He was the first person who noticed the deflection of complex needle every time the current was passed through the wire. Okay, see the picture. He was a best scientist named Hans Christian Ørsted. He only first observed the deflection of compass needle every time while the current passes through the wire. Okay. Then about electromagnet. Okay, then about electromagnet. The coil we used in the magnet. The coil here on a activity. Okay. First we want to take what? 75 centimeter long piece of insulated flexible wire. We want to take what? 75 centimeter long flexible wire and an iron nail. Okay. See the picture, ma? They have given a picture. First we want to take what? 75 centimeter long insulated flexible wire. Then we want to take what? Iron nail, say about 6 to 10 centimeter long. See the nail? It is very big, right? Then wind the wire tightly around the nail. See the picture? They tightly wrap the wire around the nail. Then connect the free ends of the wire to the terminal of the cell. See the picture? They have given cell sign. Then place some pins on the near the end of the nail. What happened? When switch off the current, what happened? Or the pin still slinging to the end of the nail? Yes, the coil in the above activity behaves like a magnet. Okay, it attracts the pins, which when electric current flows through it, okay, while the current passes through it, what happened? The pin sling into the nail. When the electric current is switched off, what happened? The coil generally loses its magnetism. Such coils are called what? Electromagnets. Okay. While current passing, the pin or slinging in the nail. If the current off means what happened? It loses magnetism. Okay. The nail lose the magnetism. It is called what? Such coils are called what? Electromagnets. Then about electric bell. We have all seen this bell, right? In some schools they are using this type of electric bell. Okay. Here the coil acts as a electromagnet here also. Okay. Here also the circuit of electric bell consists of what? Coil of wire wound on a iron piece. Okay. See the picture? They have used some coil of wire, right? The coil acts as a electromagnet in this circuit. So a iron strip with a hammer at one end is kept close to the electromagnet. See the picture? The iron strip Left side there is a iron strip hammer. At one end is kept close to the electromagnet. There is a contact screw near the iron strip. See the picture? There is a contact screw also. There is one screw. Then when the iron strip is in contact with the screw, the current flows through the coil which behaves as an electromagnet. Then it pulls what? Iron strip. In the process, the hammer at the end of the strip strikes the gong of the bell to produce what? Sound, because there is an electromagnet. Okay, while the current passes through, what happened? The iron strip hammer at the end strikes the gong of bell. It produces what? Sound. The current through the coil stops flowing. Okay, the coil is no longer an electromagnet. It no longer at the iron strip also. It comes back to the original position. Okay, if the current flows means it react, it produce what? Sound. If there is no current, it comes back to its original position. Okay, this is about electromagnet. Okay ma, that's all about today's topic. Okay, thank you.